Hello friends, in this video we are going to study about isomerism in coordination compounds. What is isomerism? It is about studying isomers. What are isomers? Same molecular formula but different structural formula. The compounds possessing similar molecules, same molecular formula but exhibiting different structures are called as isomers. Okay, there are two types of isomers we study here in coordination chemistry as we do in organic chemistry. One is structural isomers, the other one is stereoisomers. Structural isomers means there will be a profound change in the structures. Molecular formulas same, but structure will be different. The different in the sense there will be difference in terms of ligands, in terms of central metal atom, in terms of ligating site. So there will be a profound change in the structures. Okay, they are structural isomers. But in the stereoisomers, if there is a difference in spatial orientation of ligands, okay, then they can be called as stereoisomers. Here in stereoisomers, molecular formula is same, structure is also same. The only difference is spatial orientation of ligands. Okay, the orientation of ligands in the space that varies means they are stereoisomers. And if those stereoisomers are able to rotate the plane polarized light clockwise or anti-clockwise, then they can be called as optical isomers. If not, then they are simply geometrical isomers. Okay, so in this video we'll concentrate on structural isomers, and in the next video we'll go to stereoisomers. Okay, structural isomers are classified as ionization isomer, hydrate isomer, linkage isomer, coordination isomer, coordination position isomer, and polymerization isomer. Let's begin with ionization isomer. Look at this. Okay, there is a molecular formula, similar molecular formula as I said, and it exhibits two structures. One is red-violet. One isomer is, its color is red-violet, and it gives precipitate with barium chloride. The other isomer is red in color, and it gives precipitate with silver nitrate. If you get a precipitate with barium chloride, means what is that? It is a test for sulfate ions. Okay, that means there is sulfate ions present in it. Precipitate with silver nitrate means what is that? Here there is a bromine, that means it is a test for bromide ion. Okay, so here silver bromide is precipitated. Here barium sulfate is precipitated. So barium sulfate is precipitated means sulfate is outside the sphere. Sulfate is outside the sphere. Then what is inside the sphere? What is write the remaining thing? Cobalt, pentamine. Okay, so pentamine, bromo, cobalt 3 sulfate. Okay, this is one isomer where sulfate is outside. That is why you get a precipitate with barium chloride. And here, as I said, bromide is outside the sphere. So bromide is outside the sphere. So what is inside? Write the remaining thing. Cobalt, pentamine, sulfato. Pentamine, sulfato, cobalt 3 bromide. Okay, so these are the two isomers having the same molecular formula. Okay, so how did we get this isomers? Okay, there is bromine inside, but it goes outside and sulfate comes inside. That means SO4. That means ions are exchanged between coordination sphere and the ionic sphere, ionization sphere. Okay, then we'll get ionization isomers. Look at this. This is obtained by exchange of ligands between coordination sphere and ionization sphere. Okay, let's go to hydrate isomer. This is also a stereo, this is also a ionization isomer, but we specially call it as hydrate isomer. So this is a molecular formula. It exhibits three isomers. One is violet, other one is green, other one is dark green. When they are treated with silver nitrate, the first one gives 3 molecules of silver chloride. That means 3 Cl minus, 3 chloride ions are outside the sphere. And here 2 silver chloride, that means 2 chloride ions. 1 silver chloride precipitated, that means 1 chlorine is outside the sphere. So write down the first one, 3 chloride outside the sphere. So what is there inside? Write the remaining thing, chromium, H2O, 6. Hexa aqua chromium 3 chloride. This is the first one, violet color complex. And next one, 2 chloride is outside. 2 chlorides outside. So write the remaining, chromium, 2 chloride outside means 1 chlorine comes inside. Write the remaining, H2O. This is an octahedral complex. So already there is 1 ligand. So write the remaining as 5. So 1 water molecule comes out of the sphere. So this is the violet green complex that gives 2 chlorine, 2 silver chloride. That means 2 chlorine outside. Okay. Third one is 1 chlorine outside. So 1 chloride. Write the remaining thing. Chromium, 1 chloride outside means 2 chlorine inside. So next H2O, 4. So 2 H2O outside. Okay. So this is also an ionization isomer because there is an exchange of ligands between the coordination sphere and ionization sphere. However, we specifically call it as hydrate isomer, because here there is 6 water molecules, here 1 water molecule comes out, here 2 molecules come out. As a result, since the water molecules are exchanged between the coordination sphere and ionization sphere, we call it specifically as hydrate isomer. Okay, this is obtained by when water molecules are exchanged between coordination sphere and ionization sphere. Okay, and let's see the next isomerism. This is coordination isomerism. Coordination isomerism. Okay, look at these complex. Okay, here there are 2 spheres. These 2 are isomers, the first one and second one, both are isomers, structural isomers. Look at the first one. There are 2 coordination spheres. Generally what we have seen is a complex means there will be a sphere and there will be counter ions outside. Coordination sphere and ionization sphere. But here it is not like that. Positive ion and its counter ion, both are coordination spheres only. Okay, this one is hexamine cobalt 3. So its charge is +3. This is hexacyano cobaltate 3. So here its charge is 3-. So cation, anion, both are complexes. Okay, both are coordination spheres. Okay, in this sort of complexes we observe coordination isomers. What is happening? Look at this. Look at this. This chromium from this sphere goes to this sphere, and this cobalt from this sphere comes to this sphere. That is why you see chromium comes to this sphere, and all the cyano ligand remain as such, and cobalt come here and amine remains as such. Okay, so exchange of metal from one sphere to other sphere. Okay, that is coordination isomerism. Look at this, linkage isomerism. Linkage isomerism is observed when there is an ambidentate ligand is present in the complex. What is ambidentate ligand? Take for example, let's take nitro. Okay, it can be written as this nitro, we can call it as nitrito. This nitrito can coordinate with the metal through nitrogen. Otherwise, it can coordinate with the metal through oxygen. So same ligand, it has 2 coordinating sites. Okay, that is why it is called as ambidentate ligand. So in this case, it can be written as nitrito N. Here it is written as nitrito O. Okay, look at this complex. Here nitrito through nitrogen it coordinates, here through oxygen it coordinates. That is why pentamine nitrito N cobalt 3 chloride. Here it is pentamine nitrito O cobalt 3 chloride. Okay, and there are other ambidentate ligands as well. It can be cyno or NC, isocyano, or SCN, thiocyanato or isothiocyanato. Okay, these are also other examples for ambidentate ligands which can give linkage isomerism. Okay, next one is coordination position isomerism. Look at these two complexes. Okay, they both are isomers, coordination position isomers. And this complex is a little different from the previous one because there are two metals and these two metals are connected by bridging ligands. Okay, here amido bridge, here it is hydroxo bridge. Okay, so in this sort of complexes, this isomerism is exhibited. Look at this. In this cobalt side, there are 3 ammonia, 1 chlorine. This side, 3 ammonia, 1 chlorine. That means almost symmetrical. Okay, so what happens? The chlorine from this side to the other side, okay, moves. Okay, that is why instead of here right side, left side, chlorine is missing and you get 2 chlorine. And ammonia, 1 ammonia from right side to left side moves. That is why the 3 ammonia becomes 2 ammonia, but here you get 4 ammonia instead of 3. Okay, so what is happening? Ligands are exchanged from one metal to the other metal along, okay, one metal to other metal separated by bridging ligands. Okay, one metal to other metal separated by the bridging ligands. Ligands are exchanged. See, exchange of ligands between the metals linked by bridging groups. Okay, so the metals linked by bridging groups, okay, from one metal side to other metal side, the ligands are exchanged. As a result, you get coordination position isomerism. Look at this. This is the last one, polymerization isomerism. This is a little special, okay, and this is unique as well. Okay, actually this is not a real isomerism. Why? Look at these. This one and this one. These two are isomers, but see how many platinum here? 1 platinum. Here 2. Okay, and here 2 ammonia. Here 4 ammonia. That means 2 times of ammonia. Okay, 2, here 4, 2 times. And here 2 chlorine, here 4 chlorine. This is also 2 chlorine, 2 times. Okay, so that means what? That means what? What is the definition here? Isomerism means same molecular formula, different structural formula. Here, where is the same molecular formula? Here everything 1 platinum, 2 ammonia, 2 chlorine, but here 2 platinum, 4 ammonia, 4 chlorine. So it is multiplied by 2. So same molecular formula is not there at all. So we can't speak about isomerism here. That is why this is actually not a real isomerism. However, we put it in the folder of isomerism because as I said, here everything is multiplied by 2 here. Okay, instead of 1 platinum, here 2 platinum. Instead of 2 ammonia, you have 4 ammonia. 2 chlorine, you have 4 chlorine. Multiplied by 2. Okay, so in that case, if I say that this is a monomer, this is a dimer. Okay, that is why it can be called as polymerization isomerism. And look at this word, same empirical composition but different molecular composition. Anyway, isomerism means there should be some similarity. In the previous case, what? Structure varies but molecular formula should be similar. But here, molecular formula is not similar. However, you need to get some similarity, then only you can put it in the folder of isomerism. So what is the similarity between these two? This is a monomer, this is a dimer. Okay, what is similarity? If you assume that this is the if you assume this X, then this is going to be 2X because 2 platinum, 4 ammonia, 4 chlorine, okay, multiplied by 2. So if this one is called as X, means this one is called as 2X. So what is common between these two? X is common, isn't it? Take X, you multiply by 2, you will get this isomer. Take X, you multiply by 1, you will get this isomer. So what is common between these two? X. X is common. So in that case, X is the empirical formula. What is empirical formula? You would have studied. If you take benzene, let me say C6H6. Okay, this can be written as C1H1 into 6. So the C1H1 is the empirical formula. This empirical formula is multiplied by a whole number, you will get a molecular formula. Okay, so that's what I say here. Here X is the empirical formula, multiplied by 2, you will get the molecular formula of this complex. Take this X, multiply by 1, you will get this molecular formula. Okay, so same empirical formula, empirical composition is same. Okay, but molecular composition is different. Okay, this is all about polymerization isomerism. I hope you understood. If you have any queries and comments, write it in the comment box, and we'll meet in the next video with some other interesting topics. Wish you all the best. Thank you very much.